Welcome to NOAA Live Alaska. My name is Lisa Hiruki-Raring, and I'm going to be moderating today's webinar. This series is a collaborative effort between NOAA Fisheries Alaska Fisheries Science Center, where I work, NOAA's Regional Collaboration Network, and NOAA's National Weather Service. This webinar series is designed to help you get to know NOAA's work in Alaska and how we connect and work with your communities. NOAA, the National Oceanic and Atmospheric Administration, studies the ocean and the atmosphere and where the two meet, from weather to ocean to the animals that live around us. All of our speakers work for some part of NOAA or work in partnership with NOAA. We hope this gives you a sneak peek at different careers and career paths that you might be interested in. Today, we're introducing you to Peter Murphy, who's the Alaska Regional Coordinator from NOAA's Marine Debris Program in Seattle, Washington. While we'll be talking about NOAA's role in research and stewardship, we want to recognize that we are all coming to you from the traditional lands of Native communities who have substantial traditional and local knowledge and much to share with us. NOAA's Marine Debris Program does work in all coastal waters of the continental US. In Alaska, Peter's work is conducted all along Alaska's coastlines from the Arctic to Southeast Alaska, which from north to south are the traditional home waters of the Nupiat, Yupiat, Anunga, Alutiit, Iyap, Tlingit, Haida, and Tsimshian people. We'd also like to acknowledge that Peter's presenting from, and we are also hosting this webinar from, the traditional lands of the first people of Seattle, the Duwamish people, past and present. A few guidelines before I hand you over to our speaker. You're all muted because we have a lot of people on the line and we want to make sure that everyone can hear our speaker. However, there's a box where you can write questions and we encourage you to ask them as we go because we want to have a lot of interaction between you and the speaker. My colleague Chris Beyer and I will be keeping track of questions for Peter behind the scenes. He'll be stopping every now and again to answer a few questions. We might not get to all of your questions, but we'll try to answer as many as we can. All right, I'll hand it over to Peter to introduce himself.
Hello. Sorry, I'm going to stand up now. So, can you hear me okay?
Yep.
Great.
We can hear you fine.
The audio check. So, again, my name is Peter Murphy. I'm so excited to be able to come and talk to you today about marine debris, a topic that I've been working on for some time and really passionate about. And it's great to hear people from all over the country who are online today to hear about this topic, what we're doing about it in Alaska and beyond, and what you can do about it too. That's going to be a key part of this. So with that, I'll jump right in. So don't know if you guys are at the age where you're just having to do outlines for your papers or something. I never stop doing outlines for things. I find them super helpful. So this is an outline of what we're going to talk about. So first, introduction. So basically, why am I on your screen talking to you about this topic? Why is it me? How did I start working on this? It's kind of a random topic, right? Random job. So how'd you get into it? The marine debris, well, what does that mean, really? Why does it matter? There's a lot of things going on in the world. Why do we care about this? Why should we? Where it comes from? Where is it? And then Alaska marine debris. And then what can we do about it? And actually, emerging topics can be first. You can kind of flip that around a little bit. But anyway, so emerging topics, kind of new things going on. And then what can we do about it? So that's elements that we can all work on together. And of course, a thank you. And just to kind of give you a picture of what you're looking at there on your screen, the upper right image is from Montague Island in the Gulf of Alaska. Just the outside of Prince William Sound, really shows a really high energy beach. You see all those logs, that are kind of naturally occurring items that wash up on beaches, right? But then in among that, you see those brightly colored man-made objects, objects like buoys and floats, other things. So it really shows how much stuff can show up. And at bottom right is a picture from Kayak Island, also in the Gulf of Alaska, of people removing debris using a helicopter. Which shows a lot of innovative ways that people work on the issue, which we're going to talk about again in a minute. So, a little bit of introduction about me. I usually don't like talking about myself, but they asked me to, and I like to do what I'm told. So, or asked to do. So anyway, a little bit about me. So I grew up always being fascinated with the ocean and with how things work, whether that's with machines, or natural phenomenon like storms, why is it raining, why is there lightning, why is this happening, all those things. And so I got the opportunity to work on a lot of those different things in school and learn about them. And then after school, I had the opportunity to come and work at NOAA. So I started working on marine debris about 13 years ago, so 2007, working down in Gulf of Mexico. But then pretty soon after, I got an opportunity to start working on Alaska, which I was so excited to do. I grew up really fascinated with Alaska. Actually, my dad worked in Alaska on a lot of different things, different topics and different projects in science as well. And so I got the chance, it was great to be able to continue that. So the job I do, I get to work on marine debris and understand what it looks like. Marine debris is different. It's similar stuff, as we're going to talk about, but where you are, it makes a difference. So Alaska is a unique place, and debris is unique too. And through this job, I got to do some really cool stuff, really exciting, working in Southeast Alaska, as well as that picture at the bottom right is from the Pribilof Islands out in the Bering Sea. We were moving a vessel that was having impacts on animals and on habitat. And then at top right, that's a chance me getting out to actually go out in and work, interact with the public. It's something else we get to do is talk with people, just like I'm doing today. It's one of my favorite parts of the job. So it's a great job, and I feel really lucky to have it. So, marine debris. What do we mean by that anyway? So, when you see green text on the screen, that means that there's a question. So, what kind of things do you guys normally see when you visit the beach? So, what are some things you see on the shoreline that you regularly, when you're out there? So, you guys can type in what you see or what you're used to seeing, and then they'll read it out and we can talk about it.
So if you see the question box on the side of your screen, if you want to type in what you would normally see when you visit the beach. So think about all of the different beaches that you go to. Some of you guys live in different areas and might have different kinds of beaches. But what we're seeing, let's see. So Devin is saying plastic shovels. Eve and Jasper are saying wood, kelp, rocks, and shells. Heather is saying balloons, cigarette butts, and boat debris. Karen is saying tires. Mary is saying trash, buoys, rope, and sticks. There's sands, plants. Tyler from Facebook is saying plastic.
Okay.
Heather is saying good things are kelp and shells.
Right.
Yeah, so there's a lot of different things that people are seeing on the beach.
Yeah, exactly. And those are all great things that people have seen, great input. I really appreciate you guys typing it in. And that shows there's a lot of stuff that shows up on beaches. It has gone for a long time, right? So, in these images on the screen right now, on your left side, you see kind of what we picture a beach we would hope it would be like, right? You see sand, you see wood, maybe there's an ATV there, someone's kind of getting out and about, which is great. People are out able to enjoy. It's a sunny day, it's also nice. But you can see there's not a whole lot of other stuff, a lot of other things on the beach. But on the picture on the right, that shows a lot more of what other people are mentioning for stuff that maybe you don't want on beaches, like cans and water bottles and green plastic jugs. So really shows what we're talking about with debris items is different types of things that we obviously don't want to see on beaches. So as somebody said, oh, the things that we like to see and the things we don't like to see. That's exactly right. So thanks for all that input. So what we say when we talk about marine debris, we're talking about things that are persistent and man-made. And we'll talk about that in a minute. But really, it can be anything from tiny to large. So people mentioned all sorts of different things in that, even vessels, which we have on the screen here. But one of the things I want to kind of point out is at the top in the middle, you see that's a piece of microplastic. So that's actually a piece of plastic that was designed to be that tiny. And actually I have here, I will hold it up to the screen, the camera. That is actually microplastics that were actually from facial scrub. So stuff that you use to wash your face. We rinsed it down and found these tiny little bits of plastic that are in there. So they're really good for getting dead skin off your face, but they're not so good when they get out into the ocean. That's an example of these tiny little bits of plastic, and they can have impacts. But then you get to much bigger things, like at the left side, you see consumer debris. That just means stuff that people use every day, like water bottles or totes or plastic, plastic grates, plastic lids, that sort of thing. And then at the bottom in the middle, you see crab pots. So I don't know how many of you guys go crabbing or lobster. I heard somebody when I thought maybe that's Far Harbor, Maine, maybe it's a different part of the country. But people go out for fish for different things. Derelict fishing gear, when it's out there, that can become debris. And then at bottom right, you see vessels. So actually old boats, those can be a big problem too. people don't have the time or money to keep up with a boat, and maybe they just leave it. But then that can cause real problems for the habitat, for the beach or the shoreline, wherever it is. And then also it can be worse as the boat breaks down and creates more debris itself. So one of the things when we say marine debris, what does that really mean? Well, we could define it. So, when you work in science, you have to make sure that you're talking about the same thing. So use definitions, right? So here's how we define the word: persistent man-made material. So man-made means things created by human processes. So the actual dictionary definition is made or caused by human beings, as opposed to occurring or being made naturally. So thinking back to that picture just a minute ago of the beach, you look at, there's wood, and that's like a debris item that could wash up. But that's natural, right? It comes from nature. Whereas those other things like cans, those are made by people. That's something that we try to really emphasize is all debris, no matter where it came from, started as something that a person did or made. And then persistent. So that means things that last a long time. So the definition again, continue to exist or endure over a long period, or long period. So that image on the right-hand side shows you, like fishing nets are a good example. So that net, the top one, that's an old fishing net. And nets used to be made out of rope, which is made from organic materials. So cotton or hemp, those sort of things. Not just the cotton usually, but hemp or other kind of long-lasting material people would use. But eventually that stuff would break down. Now, nets are made out of plastic. So I have a net behind me. I also have this piece of net. It's like a trawl net piece, or a very tiny piece of a trawl net. Obviously, nets can be very, very large now. But these items, when they get out in the water, they last for a really long time. That means that they can impact things for a longer time. So we're going to talk a little bit about persistence. Oh, in a minute. Sorry, my presentation had a slight problem there. So why does it matter? First, marine debris can cause a lot of different problems or impacts. So a question for you guys, again, green text, so it's a question for you. What are some impacts or problems you can think of? What are things that marine debris can do or impacts it can have on people or on the environment or on animals or anything else?
So I can see some hints from the pictures that you have up on the screen. I'm getting some folks that are typing in now. Maria says that it can kill animals by strangling them or getting into their bodies. Mary says that it can kill animals. Mrs. Hemphill's class says that fish can eat it.
Yeah.
We are having some other folks. Let's see, Javen is saying in Alaska there's fishing line removal stations, so there are places where you can get rid of things that could become marine debris.
Awesome.
Maria says that microplastics can also get up the food chain into our food. India says that it can hurt animals, and Heather says that it can be a navigation hazard to boats. So that sounds like there are a lot of different impacts.
A lot of different impacts and a lot of great inputs. Thanks, guys. Really appreciate your thinking through it. And you hit the nail on the head, each one of them. I mean, really, and this gets to two of the things you guys said. Animals can eat the things, whether that's different kinds of plastic, or they can get caught in it. So the words we use for that are ingestion and entanglement. And ingestion is really just like you guys said. It's animals that actually eat plastic, whether they eat a smaller animal that already ate plastic, and so then they have it inside of them. So a fish eats a smaller fish which already had plastic in it, or a different type of animal. Or it can be direct, meaning they actually just eat the plastic, whether that's by confusion, they think it's supposed to be something else, or for other reasons. So the image at top, that's an image of a seabird out in the northwestern Hawaiian Islands, so in the middle of the Pacific Ocean, pretty much, or at least close to the middle. You have these islands where they have these large animals, but they also have a lot of marine debris that washes up. So these animals actually eat. You can see, that's an animal that's died. You can see that it's got where the stomach would be. You have bottle caps. You have all sorts of these plastic items. Sometimes the scientists think that they can eat that because they confuse it with food. Other times, some animals actually ingest rocks on purpose as part of their digestive process, and so they can mistake it for that. But you have these impacts that can cause real problems, whether that's mechanical, like the animal gets it inside of itself and can't get rid of it, and so that causes problems for its stomach and its digestion, or it can't get enough nutrition. But also, then at the bottom right, you see an image of entanglement. So that's a whale off the coast of Hawaii that's actually, a team is going to disentangle it, so to remove that buoy, or those buoys and line from it, which which is great. But a lot of animals don't have that. They don't have someone to rescue them, so they can get caught. And so then we see them come ashore, and that can mean that they can't eat as well, they can't swim as well, they can't reproduce, and then oftentimes too they can die. And so you can see impacts up and down the chain. Other impacts we see are something we call ghost fishing. So it's kind of like entanglement, but it's a little different because this is the feature or problem that marine debris that's like derelict fishing gear, so old fishing gear that gets lost, continues to fish for a long time, but it doesn't just catch what it was meant to. So, like the net behind me here, or the one I showed you before, those are designed to catch a specific type of animal, like salmon or whatever it may be. So these nets continue to catch for a long time. Work we did actually showed that the bottom right image, derelict crab pots that got lost continued to catch crab for up to 7 years past when they went into the water. So it can be a really long time that you have this gear continuing to ghost fish, and that can be a really big impact. So that's our first kind of section, a little bit just kind of about marine debris in general. So with that, I wanted to ask if there are any questions folks have.
So if you guys have any questions, please type them into the question box. I did have a question from India who wanted to know about the animals that you just showed in your ghost fishing slide, and she wanted to know, how did it die? How did the animals in those nets die? And I think that you had described the ghost fishing part of it.
Right. So most often, animals that get caught, depending on their species, a lot of it, if they get caught, then they can't breathe. So whether that's a mammal or other animal that needs to return to the surface to breathe air, then obviously they can't do that, so they would die that way. Also, other animals, if it's a fish, then obviously they need to move in order to get oxygenated water through their gills. So a lot of it has to do with breathing, but other animals like crab or other animals that get caught in a crab pot, then they cannot have enough food because they're stuck in there for so long. Or we actually have we have video when we were doing research on crab pots of a bunch of crab were caught in an old pot, and another animal came in and actually opened the crab pot and ate them. So it can be a lot of different ways, but really it comes down to they're not able to do what they need to do to stay alive when they're in one of these.
Great. And then following up on the ghost fishing question, Maria had wanted to know, how common is ghost fishing and how big of a problem is it?
It can be a really big problem. So data from across a lot of different fisheries has shown that it's not uncommon for about 10%, for example, in trap fisheries. So fisheries where they use crab pots or lobster traps or different traps. It's not uncommon to lose about 10% of the gear in a given year across different people. So obviously these fishermen, fisherwomen are very good at what they do, otherwise they wouldn't do it. But just things happen, and other boats can come and hit the line. The tides there can be a storm, all sorts of things happen. So it can be quite common for nets or pots to get lost or snagged or otherwise go overboard, and then there can be impacts. And so it's definitely something that we see in the US and then globally too. It's an area of concern.
Cool. Wow. And then we have one question from Mary before we move on to our next section, which is, have you ever, let's see, what is your favorite part of your job?
That's a hard question. I like a lot of my job. I'm very lucky to say that. I think two things I would highlight are, one, getting to meet people who work on this topic. Marine debris is my first job. It's my day job. It's what I work on. That's the thing I focus on. There's a lot of people who do amazing work with marine debris who are a seabird person or a seal person or a whale person. And I mean that's what they focus on. They're not a whale themselves. But they focus on this topic, and then they get interested in marine debris and they do amazing work. So getting out to meet with those people and hear what they're interested in, hear what they're learning, so that I can take that back and share it with more people, that's one of my favorite things. And of course, getting to go out in the field and get to do great work and work with those people, actually, like on the beaches, on the water. That's always fun. Most of my job is at a desk, and I'm cool with that. Someone needs to do it, but it's great to get out in the field too.
Wow, great. Yeah, that sounds like a great part. All right, well, let's get to the next part of your talk, and as people think of questions, feel free to type them in, because Chris and I are keeping track for Peter.
Great. All right, well, since we just had questions, we'll skip this one. But I want to talk a little bit about Alaska. I know we have folks from Alaska on the call. Thank you guys. So you guys, this will be a review. We have folks from other parts of the country too. So just a little bit of Alaska, which may be review for some, but new for others. Size. People know Alaska is a big state, but it is important to know that Alaska is double the size of the next state in the United States. I like that image, the top right. It's older, it's maybe oldie-timey, it's an old postcard, but it just shows Alaska superimposed on the lower 48. So you have Alaska going from the Carolinas all the way to California when you take into account the aleutians of how just big it is. And it goes along with that shoreline. It has more shoreline than the rest of the whole United States combined, depending on your estimate, 40,000 plus miles of shoreline. Landscape, it's rugged, but it's diverse. So, you from Southeast Alaska, the old trick. So you hold up your hand like that, that's kind of like Alaska. So Southeast is a thumb. If from Southeast all the way up to the Arctic, it's very different. So it's not just one type of shoreline. And so you really get a lot of different challenges and questions and things to worry about. In Southeast, there's storms, there's all sorts, there's also these inland fjords. But then up in the Arctic, you have to worry about ice and all of that. So it's very different. And then population, relatively few people in terms of per square mile. There aren't very many people that spread out over the state, and many in small communities. And so that creates its own ways that things are done that have significant benefits, and also at times can create challenges. You don't have as many people around to work on things, and they have a lot going on. So just to say that working in Alaska on marine debris is different than other places. Every place is unique. I would argue Alaska is maybe especially unique, given how big it is and how different it is. But it's a really fascinating and amazing place. So debris gets to Alaska. How does that happen? Well, data shows that most debris in the oceans, some data shows as high as 80%, it's hard to exactly estimate, but comes from introduction on land. So that means it wasn't thrown off of a boat or lost off of a boat directly into the ocean. It started off with a disposal or an accident or a mistake on land, and then it washes out. And, we're all upstream from the ocean, right? So in these images, you see, trash that was probably lost on a street, maybe a playground, wherever it might be, washed it down a sewer, and then to a river, and then out into the ocean. So the point is that debris can really travel. It doesn't know boundaries or borders. It moves to wherever it's going to go. And then how does debris actually get onto shore? Now it's actually out in the ocean. It's gone down the river. It's in the ocean. Okay, well, what happens now? Well, debris is influenced by two key factors where it moves, and that's winds and currents. So we'll talk about currents first. So you see that map at the top, the left, the one with the red and blue arrows. That shows some of the big current patterns. And there are these patterns that the currents tend to move a predictable way. For people who go out to the ocean, or people who go out in boats, this. The currents usually go a certain way in different places. So if you zoom in a little bit, that's still a massive area, the North Pacific Ocean, you see that there's the patterns there. So the Kuroshio current off the coast of Japan moves up kind of clockwise, an oval pattern, becomes the North Pacific current, which as it approaches the North America, splits north into the counterclockwise Alaska current, the Gulf of Alaska, and down into the California current. So what that means is debris that's in the North Pacific Ocean can get pulled and moved by currents into the Gulf of Alaska and get close to shore. But then you need winds to actually move it along, to move it onto shore. And so because how an object moves depends on something we call it windage. So like that buoy that we have there, looks kind of like this one. So if that item is sitting low in the water, so under the water, then it's more going to move based on currents. Whereas an item that sits high in the water is going to be moved more by wind, because you have more area for the wind to push against. And that can mean the object moves both in a different direction, but also at a very different speed. So at bottom right, you see an image. I know it's kind of messy. There's a lot going on. The key thing I draw your attention to is just, if you look at all these lines, and these are the storm tracks in January, February, and March, so JFM, in 2010. So I just picked a year, but the general pattern, you have these storms that arc in from the North Pacific into the Gulf of Alaska. Those can bring heavy winds and high energy waves and push this debris on the shore. So now we're going to do a quick demonstration on this. See. Okay, so hopefully you can see my screen. You can see me on the screen a little bigger now.
Yep, we can see great.
Right. Okay, so I have here a tub of water. So I will try to do this without spilling said tub of water. But notice what we have in. We have. Oh, there it is.
Oh,
okay.
Yep.
We
there you
have.
go.
Yep. We have just a little bit of glare. You can see there is some fishing net in there. Now, if I place the fishing net on this side, get a little closer, you can see better. On this side, now I'm just going to blow in the water. Okay, so you notice just by me blowing in the water, it moved from the side near to me to the side far away, but kind of slowly, right? Now, I will introduce a pop can, an empty soda can. Now I'm going to do the same thing, exactly the same way. Okay, so you notice one puff, if you will, and the soda can is all the way on the far end. So the point of this is just that debris, how it moves, is influenced drastically by where it sits in the water. And that can change over time too. You have objects like, like this buoy, for example, behind me. I got this off of a beach in the Gulf of Alaska. That buoy, sometimes they can get punctured and then fill with water. Now they sit lower, so then they float different. So the point is just that debris behavior is going to be influenced by these factors. It's going to matter for where it shows up. However, Alaska receives a huge amount of debris every year because of where it sits relative to these wind and current patterns. So some of the dirtiest beaches we see, even in the whole US, are in Alaska, even if they're far away from people. Here, I'm going to turn back on my screen sharing. So what that points to is that you can have areas that are remote, but they're not clean. So they're far away from the nearest community, but there's still a lot of debris there. So this right here is you have a shoreline on the shoreline of Alaska at the top left. In the bottom, you see images that are more from tropical areas. But these are places where they're far away from a town or a large city, but you have all this debris. And that's because of these current and wind patterns that can move debris into these very remote places where you have a lot of debris and it can be really hard to clean up. So we just kind of talked a little bit about debris, about Alaska and where the debris is there and how Alaska is different, and then also how debris moves. So I want to see if you had any questions about any of that too.
Okay, so we have a couple of questions about, actually, India had a question about the bird that you showed that had the plastics in its stomach, and was asking why did the bird eat the plastic and how did it die from the plastic?
Right. So a couple of answers there. So why did the bird eat plastic? Well, there's different reasons different animals eat plastic. One, they can mistake it, so meaning they think it's something else. So an example is, I'll show it to you later, but a plastic bag, like a shopping bag, there's evidence that some animals might look at that because of the way their eyes work under the water and think it might be a jellyfish, something they eat. So it's a mistaken identity problem. So they think they're eating food, but they're actually eating plastic. Other times, animals can eat it because they eat something smaller that already ingested plastic. So they eat a smaller fish or something else that they're supposed to eat, but that animal had plastic in it. So you can see uptake that way. And then also sometimes there can be also kind of, it's a little different because they might not think it's food, but some animals ingest objects like for their digestion purposes. So that can be a mistake, but that's the case. As far as how the animal died, there can be multiple different ways. One thing is just false satiation, but it's a fancy word just saying they think they're full, but they're not. Their stomach's actually full of plastic, so they don't eat, so they don't get enough nutrition. They don't actually eat food, and so then they die because of that. Other times it can be actually the blockage, so meaning the plastic gets inside, they can't get rid of it, and so it blocks everything up, and then that causes all sorts of problems for their digestion, and then they're not able to survive. So it can cause a lot of different problems in different ways, and there's a lot of work going on to understand that better.
I had a question about the demonstration that you did,
Yeah,
and you showed that the net was lower in the water, so it didn't go.
yeah,
The wind didn't affect it quite as much as the empty can. Do
yes.
you have a way of measuring that kind of how affected by the wind these pieces of debris are?
Yeah, so there's a thing called a windage value, WINDAGE, so windage. What it means is it's actually a measure. It's like a number. So usually from like 1 to 5, 6, 7, something like that. But anyway, that measures is, okay, the windage value is how much of the wind is applied to the object. So the higher the number, the more it's influenced by wind in terms of speed and direction. So yeah, you can do that. You have to do experiments to figure it out, and there's a lot of variation. As an example, back when the tsunami struck Japan in 2011, the Tohoku earthquake and tsunami that followed, we have a lot of evidence of examples of objects leaving the same location at the same time. A specific example, there were 3 docks that left, one large docks, 40 or 50 feet long, that left the same port at the same time. They were all washed out, but they ended up in drastically different places. So one ended up on the West Coast, and then a few months later, one missed Hawaii, and a few months later, another one washed up on the West Coast. But they all left the same place at the same time and should have behaved the same, the same shape and size. So even though you can do that, it can be really hard to tell where something's going to go, just because of all the variables involved, all the different ways that the ocean behaves and items behave in the ocean.
That's really interesting. I never thought about different things taking different amounts of time to get to the same place.
Yeah,
Maria
or
actually
going
had
in drastically different directions. It's amazing the variability.
yeah,
Yeah.
definitely. Maria had a question about saying if there's more debris on Alaska beaches, then do a larger proportion of sea animals die in Alaska from that debris?
Good question. So I think the shortest answer is we don't know, because part of it too is that different debris impacts different animals, and so you need to have, if you're going to have an impact, you obviously have to have the animals interact with the debris somehow, whether they eat something, whether they get tangled in something, whatever it may be. And so we're always working to better understand the numbers, like try to quantify, count how much impact debris has. But we do know that there's more debris on some parts in some parts of the world on beaches, and that could create more in the ocean for animals to interact with. But that's one of the challenges of debris is, you look at the ocean, it's hard to actually see into it and see what's happening, right? Just mechanically. And so we're always trying to find ways to count that. So sorry, I can't say like yes or no. That's one of the challenges of science, right? Is we're always trying to find and explore questions and find answers, but oftentimes that leads to more questions.
Well, and that's kind of where your job of doing research on marine debris comes in, I guess.
Right.
All right. Well, maybe we should move on to our next section, and then we'll stop for questions a little later.
Great. So we have 2 more sections to go. So first, microplastics. So we're talking about kind of some new things. I mentioned microplastics before. So something I want to point out or talk about is where microplastics come from. Maybe you've heard this. So microplastics start with plastics, right? So plastics are a common form of marine debris. They're non-biodegradable. So like an example, like I have this orange here, a little satsuma. So this, what would happen if I left it on a desk for a long time, right? It would get moldy, right? So what that means is things in nature are going to start to actually digest this and break it down, derive energy from this little orange. And so eventually, over a long enough timeline, it would just break down and it'd be gross, it'd be pretty much gone. And it'd be broken down into its component parts. Plastic doesn't work like that. Even as it breaks down, the only way that plastic breaks down is photodegradation, we call it. So big things become smaller and smaller and smaller, but still at the end of the day, it's plastic. And so that means that it sticks around for a huge amount of time in the ocean or in the environment. So it's estimated that about 8 million tons of plastic entered the ocean in 2010 as an example. And that's like an ongoing number. We'll estimate that that's happening every year. And that breaks into these smaller and smaller pieces over time. So as an example, you might have a water bottle like this. But what's going to happen with this is it's just going to become, over a long enough timeline, thousands and thousands of pieces of microplastic. When we say microplastic, what we mean is plastic pieces smaller than 5 millimeters in size. And so you see it's in the news a lot. People are saying, wait, we found microplastics in table salt, the salt you put on your food, right? Or we found it in animals, we found it in the air. There's all these studies going on. People are really working on it. And that's important because it is it's a phenomenon that we're still working to understand. There's a few ways that microplastics happen. One is primary, but primary meaning like that was the goal. They were designed to be tiny from the beginning. So I showed you before these microplastics that are from face wash, right? So those are suspended in water. These microplastics are a little different. Sorry, the lighting's a little bad, but there you can hopefully see a little better. These are pre-production plastic pellets, or they come called nurdles. But what they are is small pieces that you use. So if you're going to make something with plastic, you melt down something like this, and then that becomes the plastic item. So if you're going to make like a little beach shovel, I got this off the beach also in Alaska. You're going to make something like this. You melt down that plastic. So that's one way. The other way is secondary, or that means again a big item breaks down over time. So light breaks apart the chemical bonds. You get tiny, tiny pieces. So we see this happening all over, and microplastics are everywhere. And so we're going to talk a little bit about some of the work that we do. So some of the research we're doing right now is looking at examples of this. If you're looking at sargassum, so that's like a type of aquatic vegetation that's in the Gulf of Mexico, like Florida, Alabama, Texas, Mississippi, Louisiana, in that area. And so we're seeing how much microplastic is in that area and what impacts does it have? Are animals eating it or not? We're also looking at the top right image, that's clams. The question of, are clams eating it? And if so, what impacts does it have? And bottom left, that's an image of actually going out to beaches and taking samples of the sand to count how much microplastic is actually in there. And at bottom right, that's an image of actually looking at microplastic at the structural level to understand, okay, what about the toxins or like chemicals and kind of bad chemicals or chemicals that can be hurtful? What's happening with those? Are they coming off of the plastics into animals? Are they staying in? And what level of impact can that have? And there's a lot more questions than there are answers, but it's important that we're trying to explore this. When I say we, I mean everyone, like people all over the world are working on these issues. These are just examples of projects we're directly engaged in, but a lot of people are working on this. And another topic I want to talk about related to that is the fact, plastics, we're seeing them everywhere now. One of that is about plastics in the Arctic. So, many of you who live in Alaska or know about Alaska know, the Arctic is an area where there's ongoing interest and challenges, especially as there's less ice. So more people are using the Arctic for shipping, for all sorts of things. So one of the things is that means a lot of people are asking the question, well, what's going on with debris in the Arctic, or marine litter, they call it. A lot of people from other parts of the world, they call it marine litter instead of marine debris. But we're working to understand that. And you can see these images on the bottom show it just like that fishing net there, that green fishing net, kind of looks a bit like one I have here right here from something that we have here it's used in Alaska and other parts of the country. And then at bottom right, a big wad of packing band, that's from Svalbard, which is small islands managed by Norway. You can see that those have packing bands, or things that we see in Southeast Alaska and the Bering Sea a lot too. So we're starting to see these objects that were common in one part and in other parts of the world become more common in the Arctic. So it's important just to know that marine debris goes everywhere. So wherever there's people and wherever the ocean can bring things to, you're going to see debris. So we're trying to understand it better to see, okay, how can we protect these areas and how can we avoid impacts? So with that, I know we talked a little bit about microplastics and about the Arctic, kind of new things that are happening or things that are emerging. So I want to see about whether you guys have any questions on it. Sorry, I'm supposed to have questions there, but I think it's a little bit of a slideshow issue.
So actually, Mrs. Hempel's class had wondered, can we clean up, or are we cleaning up the ocean of microplastics? How can kids help or get involved in cleanups?
I will answer the second part and then the next part of the talk. So I'm going to answer the first part. First part, are we cleaning up the ocean for microplastics? The answer is we would like to. The challenge is, and I wish I had a sieve, like picture like, you know, if you're straining your pasta after you cook it or something like that. I don't know how many of you guys watch your parents, or maybe you're cooks yourselves. Everyone's getting into this. But picture if you take like a sieve or a filter, in order to get the microplastics out of the water, you have to have something that's small enough mesh to catch the microplastics, right? So like here, I'll open this up. Talking about something that is, you know, that fits just on the tip of my finger. So like that. So the challenge is any animal or other thing like seaweed, aquatic vegetation that is that size or bigger is also going to get caught. So one of the real challenges with microplastics is how do you clean them without capturing everything else? So that's one of the reasons why prevention, so keeping stuff from getting in the ocean in the first place, is a really important piece, because cleanup, while it's great and we want to do it, can be really hard, especially for certain types of debris that are either really big and really hard to get to or hard to remove because of that, or really tiny, and so you have to worry about what else are you going to catch when you try to get that out. So we're going to talk more about prevention in just a minute.
Okay. Yeah, actually, that's something, and that's something that people can think about too, because I think that one part of science that's really important is thinking up new ways to tackle problems, and that's where a lot of the times, if kids are thinking about things, they have new ways of thinking about things that people might not think about. So that's a challenge for everybody in our audience, I guess.
Yeah, absolutely. We'll talk more about it, but I couldn't agree more, Lisa, that you know, sometimes big problems can require new solutions, and marine debris is a challenging one. And there's a lot of things in the world that you know take work and are challenging, hard to figure out, right? But people figured out a whole bunch of things that are so amazing. I think marine debris is an example of something like that, where people have the opportunity to really find creative solutions.
So Maria had also asked, how are microplastics harmful? And you had talked about the albatross and how seabirds can eat plastics and get full. Does that happen with microplastics as well?
Well, microplastics have different potential impacts. So one of the things is, because they're so small, smaller animals can eat them. And so the question of, you know, that you guys all probably maybe you've learned by now, you know, food web or food chain, right? Uptake. So smaller animals get eaten by bigger animals, so on and so on. So up the trophic kind of levels, right? So one of the things that we were looking at is the question of, well, wait, if smaller animals are eating microplastics, can that come up the chain, right? And so more animals can end up with more and more plastic. Now, microplastics are small enough to where animals can just pass them through, because they eat them and then they poop them out, basically. But there's the question of, if there's chemicals on the plastics, either because of how they were engineered in the first place, like, you know, you do different things to plastic, because obviously, like, as an example, this water bottle and my glasses are both plastic. They're very, very different. One's clear, the lenses are clear, but one's soft and malleable, right? One's very hard. You add different chemicals to plastics to make them different colors or different properties. So if those chemicals get released somehow, because when they're inside of an animal, then what impacts do those have? So that's one of the things people are really looking at is, do animals ingest microplastics? And if so, what happens, and do chemicals come off of this plastics into the animal? And that's the type of thing that can cause impacts, but we're also trying to better understand, because it's not well understood yet, just what happens.
Right. Yeah, so that's actually something else that you know, if any of our audience members grow up to be marine debris scientists, maybe that's something that they can tackle too.
Absolutely.
So
yeah, go ahead.
We have some people who have who put in suggestions about what we can do about marine debris, and
Awesome.
some ideas that they have. So I'll list a couple of those, and then maybe we can go through your last section.
Sounds good.
So even Jasper was saying that they carry small bags with them to pick up garbage when they're on trails or beaches, which is fantastic. Rhonda from Juneau was saying Oh, Rhonda from Juneau had a question about whether there are any animals or organisms that can actually digest plastic. So I'll probably pass that one on to you. But a lot of people are talking about beach cleanups as a way to do something about marine debris. And I know that there were folks on the Pribilofs who were actually cleaning up debris before it got into the ocean as another way to look at dealing with debris.
Yeah, absolutely. So first, I'll answer the question. So are there any animals that can eat plastics and actually break it down? For a long time, the answer has been no. There are a few studies, so a few researchers in different parts of the world are starting to identify some enzymes or microbes, so tiny, tiny, tiny organisms, right, that can break down plastics of different types. It's still early, but that's encouraging now. But that's that's not necessarily a solution, because if you have certain types of organisms that can break down plastics in a certain type of environment, you talk about 8 million tons of plastics going into the ocean every year. You're going to need a lot of microbes, and it's encouraging. Like maybe that could be a solution to some specific elements of plastic in the long run, but not there yet. So I think the short answer is not common animals, not animals that we see all the time, and even those studies are still pretty early. So I think that's kind of gets to what people are talking about, removal. Getting out and picking up debris is a key part of what we can all do. And there's ways that people can get engaged. So why don't we get started talking a little bit about those? So what we can do about it. And when I say we, I said it before a little bit, but I want to say, like, this is, when I say we, I mean everyone. So people on this call, there's things that anyone of any age can do. And there's also things that different groups across the world are doing. A lot of innovative and active people are in Alaska working on the issue on all these different categories, so removal, research, prevention. Folks are doing amazing things. And so I want to make sure that we as NOAA, we have the honor to support this community, this group that's working on this in Alaska and elsewhere. But it's a whole lot of people working on this. So removal, cleaning up what's out there, like we talked about. So mostly it's people on beaches picking up debris, going out and picking it up, putting it in bags and disposing of it. Obviously, debris, garbage in a landfill, well, that's still garbage, but that's a lot better than on a beach, right, or in the ocean. And when it comes to landfills, disposal is also an important part of that, because a lot of communities in Alaska, their landfills or disposal facilities weren't set up to take a whole bunch of debris from the open ocean that came from other parts of the world or country or wherever. So it can be important to figure out, okay, how can we dispose of this? That's where recycling, reuse, those things come in. There's some really cool things that have been done with that. Research, so learning more about where it comes from and what it does to the environment. You guys have already asked amazing questions of, hey, well, wait, if there's a lot, then how many animals does it hurt? Or wait, what about, can animals break it down? And those are examples of questions that we're trying, and we, meaning everyone, are trying to research and understand better. And then prevention. A key part of this is stop more from getting in the ocean in the first place. Once it's already in the ocean, it's really hard to clean up. Like we talked about, microplastics, how do you get it out without catching animals or other things? Debris in a really far, remote place in Alaska, how do you get there and get the debris off the beach safely and then back to a landfill? That's really hard and expensive too. So getting it out, keeping it from going to the ocean in the first place is a really big important part. So I'm going to give some examples of type of projects that have been done in Alaska specifically. So at top left, that image, that's from the Bering Sea. There's removal. They used ATVs to go along the beach and pick up debris. Notice the packing bands. So that's an example of, packing bands are used to hold together like really heavy bags or boxes. Like if you buy like a refrigerator or something like that, you might see that. They also use it in the fishing industry too. So we see that a lot, and that can be a really hard entanglement hazard. The same thing that makes it really good for carrying a heavy box, it's really strong, doesn't bend, doesn't break, makes it really bad if it gets around an animal. That's an example of cleanup, so going out in remote areas. Kayak Island, I showed earlier, that's people using helicopters, really cool. At the bottom left, that's Tenakee Springs in southeast Alaska, so just a ways away from Juneau, a short plane ride and a little longer ferry ride. But there, they actually got the whole community, and they picked up old debris from garbage, but also old debris from fisheries and abandoned housing floats. And they even actually used some of the styrofoam that came from these old floats to insulate a cabin they were building. So it's really cool. The idea is that not only can you pick things up, you can use them and find creative ways to reuse. And at bottom right, that's an image from Sitka, where they actually worked with high school students who did removal, but also research by doing counting debris. And a few research examples, again, so research going out and counting things. I mentioned before microplastics. So in Alaska, they actually did a project in Alaska and beyond where they counted debris. I said, they were taking samples of the sand. So they did that at Park Service, National Park Service, managed places in Alaska and around the country, and then compared it. And fascinatingly, although not great news, but in 2 locations in the Arctic where they took samples, the sample numbers were actually similar to the numbers in Boston, Massachusetts, and San Francisco, which aren't necessarily really dirty beaches, but there's a lot more people in San Francisco and Boston, in those areas. And this is a little bit outside of those cities than there are in the Arctic, right, in Alaska. So it shows this microplastic can get everywhere, and plastic in general, and debris in general. Another example is work in Southeast Alaska, looking at derelict crab pots. They use side scan sonar. You guys may have been on a previous call where they had side scan sonar they used for mapping the bottom of the ocean. So here we used that same technology, but used to look for crab pots. So you can see this is an area, where we use the lines where we towed the sonar, and then you can see that shadow, that bright part, is an actual crab pot. And then we sent divers down and picked them up, and that allows us to count. So people are asking, well, wait, how bad is it with this ghost fishing? This allows us to answer that question and say, okay, per crab pot, here's how many crab it can kill or catch over time. How long does that happen? And answers like that, which can help us better understand, okay, how should we do this? What should we do? What can help us solve this problem? And then prevention. I know this is work from Thinner Plastic Coastal Studies in Kachemak Bay. I know there was a previous NOAA Live on work in Kachemak Bay. In this case, school students actually went through and counted how much debris or how much waste they were generating in their lunchroom or in their classrooms, and tried to categorize and say, okay, wait, we're throwing away a lot of forks or a lot of wrappers or a lot of trays. And then they actually made changes. So the students working with the management, the school faculty, the teachers and the principal, they figured out, okay, we're going to replace these plastic forks with metal ones that we can use every day, and these styrofoam trays with reusable trays, and all these things. And then they actually went out and also counted debris on the shorelines to see, okay, wait, do we see like items like this showing up on our shoreline? So it's a really cool example of people at all ages can do all sorts of cool things, and also that they can collect data that can help. So with that, I want to talk a little more about what you can do about it. So marine debris is a big problem, but we can all do something about it. So first, a lot of us are obviously going to school or working at home, but we still have choices in what we buy or what we do. So reduce, reuse, recycle, and refuse. So just reduce how much you buy of things, especially single-use items. Reuse, so try to buy things that you can use multiple times. Recycle, like we talked about, and then also refuse. And that just means that sometimes there might be something where you say, hey, wait, that item has too much packaging. I'm going to find one that has a different has less packaging, less stuff to throw away. And then also volunteering. Like people talked about cleanups, monitoring programs, going out and collecting data. That can be a really good way. And then also staying informed. So reading about what's going on with debris, whether that's our website or other things, reading the news. There's ways to kind of stay engaged. So last but not least, I want to show a quick demonstration about ways that you can stay engaged. So I have here, and bring them over to camera, 2 lunches that are roughly the same. So I'm going to show you option 1.
So Peter, maybe,
yeah.
Peter, can you turn off your screen so that you're bigger?
Yes, of course I can. Thank you for the reminder, Lisa. Got too excited about that. Okay, better? Better now?
Yep.
Great. So option 1, you can see you have some Oreos, some Fritos, sandwich, and a plastic bag to put it in. Okay, so you have that in your mind. Option 2, you have water bottle, some chips, some crackers, and a sandwich. Okay, so pretty similar items. what do you notice? What's the difference between option 1 and option 2? You can put it in the chat box if you can.
Okay, so option 1 was the one with the Oreos and the bag of Fritos and the plastic
Option
bag
1.
to put it in and the sandwich. And
Option
option
1
2
is
Peter's going to show that one. Option 2 is the water bottle and the container with the sandwich and chips.
So it's very similar items. You have a sandwich, you have chips, you have crackers. So what do you see as the difference between these two, option 1 and option 2?
So Texas is saying that option 2 is a zero waste lunch. And Eve and Jasper are saying that option 2 is all reusable containers. Javen is saying that 1 has plastic and 2 has very little plastic.
Right. Great. Thanks,
So,
guys. Yeah, those are all really good answers. And so you guys hit the nail on the head. A couple of key things, but the key thing is, you know, 1, yeah, it's about reusable items. So it's the same kind of thing. So you have chips, you have a sandwich, you have some snacks, but they're in items that you can go ahead when you're done, you close it up and take it home, and the next day you clean it out and you put another item in, right? So it allows you to buy bigger bags of chips or whatever it is and reuse it. And somebody mentioned there's less plastic, and I want to say too, this tray, this reusable items, you know, that you might call zero waste, it actually there's a decent amount of plastic in the packaging, but you know, plastic isn't necessarily bad. It's a matter of thinking about how you use it. So an item like this, one of these totes, you can use for a long, long time, right? I don't know how long I've had these, but years. But you know, you can use them for a long time. So maybe that's there's items that are a good use of plastic. The same reason why people use a lot of plastic. It lasts a long time, it's sturdy. That's a good reason. Whereas something like maybe a plastic fork, you know, you might use that for a few minutes and then throw it away. Well, maybe that's not such a good use, because even if it goes into a landfill, you know, into the garbage, it's going to last there for hundreds and hundreds of years. So, you know, if you only use it for a few minutes, it's going to last hundreds of years. An example of thinking about how we use things and for what. It's a way that we can each help. I know it's been a big adjustment for me over the course of this job, was moving away from single-use items. But you know, can make you feel better too. So with that, I want to see if there's any last questions. Now we're coming up on the hour.
Okay, so let's see. Actually, we did have one question from before that I was actually going to pass on to you by email, but now that we have time, I can. So Gennady from Facebook was wanting to know whether you have data regarding microplastics collected by a specific kind of net called a Newston net. I don't know what that is. So
yes, so that's correct. So there have been studies, and I don't have the data off the top of my head at the moment, but yeah, we do use Newston nets. It's a type of sampling net that's often used in collecting water samples. So there has been work done with Newston nets for sampling for plastics, including smaller particles of plastics. Obviously, as you get towards the smaller and smaller sizes, then it matters how big the mesh size is of a Newston net or others. But yeah, Newston nets have been used for plastic sampling, including smaller size classes of plastics.
And he had also wanted to know about the concentration range of microplastics, but I thought that might be easier for you to answer by email. So
yeah, absolutely. I think that's probably because there's a huge amount of variation in terms of plastic concentrations based on location and also, you know, when the sample was done, all sorts of things like that. Is sure, you know, just like anything, right? If you just like the weather varies from day to day, you know, that can have a direct impact on where you're sampling, depending on the weather, what the day before, and what's come out of rivers and those sort of things. So there's a lot of variation. But yeah, I'm happy to follow up by email.
Okay, cool. And then Maria had wanted to know, how does one get the sort of job that you have?
Good question. I think we have in our team, so Marine Debris program that I work for, there's about 20 of us, just over. We have people with all sorts of different backgrounds, people who are toxicology, emergency response, you know, oceanography. So there's a lot of different disciplines. But I think part of it is really, you know, finding a way to work on the topic and to find ways on the marine debris topic in general. So people are now doing a lot more studies. But also, I think a lot of people, like I said earlier, some of the best work and amazing work on marine debris is done by people who actually work on a different thing that's related. So like an animal or a habitat, and then they see how marine debris touches or impacts that habitat. So maybe they're focused on a specific national park or a specific shoreline or a seabird or a whale species or something like that, and they do great work. So I think, to work on marine debris as your whole job, yeah, there aren't as many of those jobs, but there's more. As more NGOs and more groups get involved. But there's also ways to work on marine debris by working on different parts of science and ocean science, even on solid waste. Like, how do we dispose of this stuff? That has a big impact on marine debris. So even if it's not a marine debris in the title, there's a lot of ways to work on things that can help the oceans and help clean them up.
Great. And I really appreciate you bringing forth ways that everybody can help with reducing marine debris, whether that's removing the stuff that's already out there or preventing it from getting in or helping with research in some ways. There are some citizen science projects for collecting marine debris. I know that you had talked about nurdles, those little tiny plastic pieces. There's a project called the Nurdle Patrol where they recruit teams of students or people that are interested to go patrol their local beaches to look for those nurdles, and then they send the numbers into an online database. So I will put a link for the Nurdle Patrol on there as well. And it looks like we're coming up to the end of our time. Go ahead.
I'll just say really quick, there's also a few other things you can do. There's also a marine debris tracker app. So there's actually an app you can download and take pictures of debris and upload them, and that can be helpful. And there's other apps like hashtag-based systems, so those sort of things. There's a lot of ways to get engaged. And we definitely encourage you to poke around our website, marinedebris.noaa.gov, and see, because there's things on there too, that ways you can engage. And I'm always happy to take a phone call or an email too.
And I will put the information for those apps and the links to the Marine Debris Program on the NOAA Live Alaska website. Peter, I was wondering whether you could go to your last slide and we'll just finish out there.
Yeah, I think I'm there.
Oh, well, you just need to share your screen.
Oh, right, of course. Sorry, I went back to the topic.
That's right. Okay, so thank you to everybody for tuning into our NOAA Live Alaska webinar. We will have our sister series, NOAA Live, happens tomorrow. And we also have another webinar next Tuesday that will be on groundfish surveys. So we'll talk about how we use fisheries surveys to look at ecosystems and fish populations. So thank you again for tuning in. And thank you, Peter, for giving us all that information.
Yeah, absolutely. Pleasure to talk to you guys, and hope you have a great rest of the day.
All right. Thanks, everybody, and we'll see you next week.